You are 3 years old. Your stomach is hollow. Your mother has just given birth to a new baby and has nothing left to spare. She is exhausted, depleted, stretched thin across two children who both need more than she can give. But across the campfire, an older woman with gray-shot hair and calloused hands is cracking open a deep root with a stone. She has been out since dawn. She has gathered more than she needs. She sees you watching. She cracks the tuber open, chews a piece to soften it, and holds it out to you. For roughly 2 million years, this simple act was the engine of human evolution. The grandmother hypothesis is one of the most powerful yet misunderstood ideas in anthropology. It argues that the single most important innovation in human prehistory was not stone tools. Not fire, not even language, it was the grandmother. Think about what makes humans strange among primates. A chimpanzee female gives birth to her last infant in her early 30s. She almost never lives past 40. Her life ends when her fertility ends. But a human female stops having children around age 50 and routinely lives another 30 or 40 years after that. She spends nearly half her adult life in a post-reproductive state. In the entire animal kingdom, only humans, killer whales, and pilot whales do this. Evolution is brutally efficient. Why would it preserve a female who can no longer reproduce? For decades, biologists considered menopause one of the great puzzles of human evolution. The answer came from the savanna of northern Tanzania. In the 1980s and 1990s, anthropologist Kristen Hawkes and her colleagues James O'Connell and Nicholas Blurton-Jones were studying the Hadza people. The Hadza are one of the last remaining hunter-gatherer societies on Earth. They live in small nomadic bands. They have no agriculture, no domesticated animals except dogs, no permanent shelters. The women dig roots and gather berries. The men hunt with bows and arrows. They live exactly the way your ancestors lived for the vast majority of human history. Hawkes noticed something that did not fit the standard narrative of human evolution. The hardest-working members of Hadza society were not the young men hunting zebra or wildebeest. They were the grandmothers. She and her team measured foraging returns across every age group. They weighed everything people brought back to camp: tubers, berries, honey, meat, baobab fruit. The results were clear. Hadza grandmothers spent more hours gathering food than anyone else. Not young women of childbearing age, not adolescent girls, not the men, grandmothers. And they were remarkably skilled. Older women had decades of accumulated knowledge. They knew exactly where to dig for deep taproots in the dry season. They knew which berry patches ripened first. They knew how to smoke out beehives without getting stung. Their daily foraging yield was not just high. It was the most stable, predictable food source in the entire camp. Here is the crucial contrast. Young mothers with infants and toddlers could not keep up. A woman carrying a nursing baby cannot walk 10 kilometers through thorn scrub carrying digging sticks and a baby. Her foraging time collapses. Her children get less food. She becomes dependent on others. This is where the grandmother stepped in. Hawkes and her colleagues documented a direct cause-and-effect relationship. When a grandmother was present in camp, her grandchildren had better nutrition. Their growth rates were higher. Their chances of survival improved. The grandmother's calories directly filled the gap that the mother could not cover. She also did something subtler and perhaps even more important. She watched the toddler while the mother nursed the infant. She collected water and firewood. She mediated fights between children. She was a living safety net that absorbed the chaos of child-rearing and turned it into something manageable. This had a direct evolutionary payoff. Mothers with grandmother help could wean their children earlier. In chimpanzees, infants nurse for 4 to 5 years. The mother cannot conceive again until her current infant is fully weaned. This sets a hard limit on her reproductive output. Over a lifetime, a chimpanzee female produces maybe 4 or 5 surviving offspring. But human mothers with grandmother support weaned their babies in 2 to 3 years. This cut the birth interval nearly in half. A grandmother-assisted mother could produce 8, 9, or even 10 children over her reproductive lifetime. Each of those children carried her genes. And those genes included the ones that predisposed for longevity. This created a powerful evolutionary feedback loop. Grandmothers who helped their grandchildren had more descendants. Those descendants, male and female alike, inherited a tendency for longer life. Generation after generation, the human lifespan stretched. The genes that allowed women to live long past menopause spread through the entire population. Grandmothering did not just help individual families, it rewired the human life course. Now here is the twist that most people do not know. The extra calories provided by grandmothers did not just keep children alive. They subsidized the growth of the most expensive organ in the human body, the brain. Your brain accounts for about 2% of your body weight, but consumes about 20% of your resting energy. Growing a large brain is the most metabolically expensive thing a human body ever does. A nursing mother cannot supply enough calories from her own body to build a large brain in her child. She needs external help. Grandmothers were that help. Their foraging brought in the surplus calories that allowed children's brains to grow larger and larger across generations. A bigger brain meant better problem-solving, sharper social intelligence, more sophisticated tool-making. Those advantages drove further selection for intelligence, and all of it rested on the foundation of grandmothering. Anthropologist Rachel Caspary and her colleague Sang-Hee Lee studied the teeth of ancient hominin fossils to determine when humans started living longer. They counted dental wear as a proxy for age at death. In early Australopithecus populations, around 3 million years ago, almost no one lived past 30. By the time early Homo sapiens appeared, roughly 120,000 years ago, a significant portion of adults were living into their 60s and 70s. That is the exact period when human culture and technology began to accelerate dramatically. Symbolic artifacts appear. Long-distance trade networks emerge. Complex tools, body ornaments, burial rituals, everything starts happening faster. Coincidence? The evidence says no. Wisdom and knowledge accumulate over a lifetime. A population with living grandmothers has a collective memory that no single individual could possess. Grandmothers remember where the water is during a once-in-a-generation drought. They know which plants cured the strange sickness that appeared 15 years ago. They have the experience that only decades of living can provide. Without grandmothers, each generation reinvents the wheel. With grandmothers, knowledge accumulates. Culture builds on itself. Information that would take a lifetime to acquire is passed directly from grandmother to grandchild. This is how human culture became cumulative. And cumulative culture is the secret weapon that allowed a relatively slow, weak primate to dominate every ecosystem on Earth. So the next time you picture human evolution, do not imagine a spear-wielding hunter chasing a mammoth across the ice. Imagine an older woman with gray hair, a digging stick, and a patient smile. She is kneeling in the dirt under a hot sun. She is pulling up a thick root. She cracks it open and hands a piece to a hungry child. That child is your ancestor. That grandmother is the reason you are reading these words right now. You are 3 years old, your stomach is hollow, and an older woman with weathered hands and tired eyes is holding out a piece of food. She is not just feeding you. She is building the species that will one day write poetry, build telescopes, and wonder how it all began.